Hello guys, welcome back to our channel. Today we are going to solve logarithmic power using recursion. Okay, in our previous example we solved linear power using recursion where we implement a PMI formula. Right here we will see logarithmic power using recursion. Okay, so first thing, why we are using like logarithmic power once I did this. So let's understand why we are doing this. So what happened in our previous example, like we implemented x power n equals to x into x power n minus 1. Okay, but here we will implement like x power n equals to x power n by 2 into x power n by 2, right? So this will be our formula which we implement. So let's see this formula satisfy our condition or not. So if we will write like x power n equals to x power n by 2 into x power n by 2, so will it satisfy our condition or questions? Like if x power 18, so it will be like x power 9 into x power of 9, right? And if we are putting here x to the power 17, then what will be it? It would be like x to the power 8 into x to the power 8, but here 8 plus 8 will be 16, so one x left, so we will multiply another x here, so it will be like, okay, so what we get here, if n is even, okay, then this formula will perfectly match or perfectly satisfy our questions, right? And if n is odd, at that point of time this will be implemented, right? So let's see our high level and low level analysis. So here we will write high level analysis. Inside the first one will be expectation. So our expectation, what is our expectation? Our expectation is like PL of if x comma 1024 will be, so expected output should be x into x into x 1024 times, right? And our assumptions will be like PL of x comma 512, it will automatically produce x into x into x 512 times, right? And now we will correlate expectation and assumptions. Okay, so what will be that? That will be power linear x comma 1024, that will be like power logarithmic, this is not linear, this is logarithmic, so power logarithmic x comma 512, that is a n by 2 half of 1024 into PL of power logarithmic of x to the power 512, right? But if we are putting x comma 1023, then for now our logarithmic x comma 511, it will be half of 1022. Okay, so into PL of x comma 511 into x, one x is left, so okay, so we will multiply with it. So this formula satisfy for odd where n is odd. Okay, so now we got our formulas. So now we will implement a low level analysis. Inside low level analysis, logic implementation. Okay, so here we will implement our logic. So that will be like function PL of x comma n, right? And now here firstly we have to calculate this one. This one means what? N by 2. Okay, so here let x power n by 2, what will be that? That will be PL of x comma n by 2, this one. Okay, right? Yeah, exactly, that will be. But one more thing, in JavaScript when we divide any odd number like 3, like 1 by 2, so it will not directly giving us otherwise if we are putting here 3, so it will not giving us a 1.5, it will give us like 1.1 into e to the power something. Okay, so it will calculate in exponential. So here we will like sort out these problems. So implement some logic, extra logic, we have to mind it. So here what we write, but we will write like if n modulus 2 equals to 0, means it is even, then what? Then we will implement PL of x comma n by 2 without thinking anything. Okay, so otherwise if that is odd, so for odd it will call PL of x comma n minus 1 by 2. We have to make it even first, then divide by 2, right? And the next line will be let x power n will be x to the power n by 2 into x to the power n by 2, right? This will be our first line of code, this will be our second line of code. Okay, and one more thing, we just implement line number 2 when the formula will satisfy for this one only. Even when it will be odd, then we have to write one more term, one more step ahead, which will be like if n modulus 2 equals to 1, so it will return what? It will return x to the power n equals to x to the power n multiplied by x. So here we have to multiply extra n inside x to the power n. Okay, and now we will return x to the power n. This is simple. Now we have to call the function power logarithmic. Here x will be like 10 and we are passing n equals to 8. Okay, now in our second step we will implement stack implementation, otherwise you can call it like base case implementation. So for this we have to make a stack. This will be like this one, and here it will be like x and then n x to the power n by 2, and here it will be x power n. Okay, so this will be like third line and this will be like fourth line. Whenever first line will be executed, these value will pass inside here, 10 and 8, and so value of x will be 10 and n will be 8, and then execute line number 1. Whenever it will executed, then it will half, like it will firstly check 8 is even, so it will check here and go inside this block code. So here it will be like x comma n by 2, so n by 2 will be 4, so here it will be x 10, n by 2 will be 4. Okay, right? Okay, and then it will again pass, now it will pass 10 comma 4, it will pass here, so this one, and then again it come here and it will be this one. So line number 1 will be executed and it again call, and this will be like x will be 10 and n will be 2. Okay, and now line number 1 again executed. Okay, so now it will be like 2 and half of 2 will be 1, so here it will be 2 and 1. Okay, and then again it will go line number 1 and call, then it will be like 10 and 0. Okay, so now for a 0, if we go one step ahead, then it will be like inside minus, so we don't need to calculate in minus. So here what will be our base case will be n equals to 0, then what should it return? It should return 1. One more thing, if we notice that if we are going calculate 10 to the power 0, it will be 1. Otherwise, if we are calculating any number of to the power 0, then it will produce 1 only. So here it will be our base case, so we will implement that base case here. So if n equals to 0, then return 1. Okay, as simple as that. So now in our stack we are like executing our stack from bottom to top. Now we are finding our base case and then we will implement it from top to bottom, and one by one when we execute the line number of lines, then number of block in stack, then it will be wipe out. Okay, so here what will be calculated, this will not going to calculate, and s to the power n, it will calculate like 10 to the power 0, that will be 1. Okay, and then the line number, this will be wipe out, and the next control will be here. Okay, so here what will be the x to the power n by 2, that will be like 10 to the power 1 by 2, that will be 0. So the 10 to the power 0, that will be 1, this value. And whenever the line number 2 will execute, then it will be x to the power n by 2 multiplied by x to the power n by 2, means 1 multiplied by 1. 1 multiplied by 1 will be 1. Okay, but here we have to consider that this is odd, 1 is odd, so we have to calculate line number 3. Here line number 3, so what will be line number 3? Inside line number 3, x to the power n, which is 1, currently 1, multiplied by x, that will be multiplied by 10, which will be like resultant will be 10. Okay, for this line. And now control will 4 go inside 4, so line number 4 execute, control will return here, so these line will be wipe out, and then we have here we will calculate into the power x to the power n by 2, so here it will be like 10 to the power 2, and if we will half of 2, that then it will be like 10 to the power 1, will be 10 only. And here for this one, line number 2, when line number 2 execute, x to the power n will be like 10 into 10 to the power 1 into 10 to the power 1, so it will be like 10 to the power 2. Okay, and then here we can notice that line number 3 is not executed because the value of n is even. Okay, so it will control will go inside line number 4, and the control will be here on this line. It will be, this line will be wiped out, and here what will be x to the power n by 2, that will be like 10 to the power 4 by 2, that will be 2. And here for this one, s to the power n, so it will be like x to the power n will be 10 to the power 4, that is this one, or 10 to the power 2, that will be like 4. Okay, so on line number 2, and whenever it will go for 4, because it is even, so it will go for 4, and then it will control will here, and this will wipe out. And now x to the power n by 2, what is the value of x to the power n by 2? That will be like 10 to the power n by 2 means 4. Okay, and now for line number 2, when it execute, x to the power n will be calculated like it will be like 10 to the power 4 into 10 to the power 4, that will be 10 to the power 8. Okay, and then line number 4 will be executed, it will skip 3 because 8 is even. Okay, so it will return, so what we get x to the power n equals to 10 to the power 8, right? So now we find our proper solution, that is this one. Okay, we will implement in a VS Code. So firstly we have to do some sort of analysis on this, analyze the code. Okay, for analysis, if we notice that if we are taking like x to the power n equals to x to the power n by 2 into x to the power n by 2. Okay, for this if we will like analyze that x to the power n, if we will follow this method, then it will be like x to the power n by 2, then x to the power n by 4, then x to the power n by 8, it will be goes up to x to the power 1, right? So if we will closely consider it, then it will be, what will be found? We found like n comma n by 2. The term is n by 2, and then n by 4, then n by 8, and till 1. So here we notice that this is GP, right? So according this, if we are taking like, we are calculating for here the number of levels. Level will be like, here the level will be. So first of all, what we assume here, we will assume, let's assume there are k number of terms. Okay, so a will be n and r will be 1 by 2, right? So here a of n will be a of r n minus 1, which will be for a term. So it will be like a of k will be a of r k minus 1, right? So it will be like a of k will be n of half k1 equals to 1. So it will be like n equals to the power k minus 1. Okay, if we will take a log both sides, so it will be log n equals to log to the power 2 log 2 to the power 2. If base and base will be, both will be same, then we will only consider the power. So here it will be like log n to the base 2 equals to k minus 1. So here k minus 1 will be log n to the base 2. So it will be like k is proportional to log of n base 2. Okay, so here the complexity will be, we can see that, and log n. So for this, if we will calculate like x to the power 32, so it will what, it will go up to x to the power 16 till x to the power 1. Okay, for this one it will be like only 5 level. Okay, here it will be only 5 level, number of level will be 5. And if we are going through old method, which was x into x to the power n minus 1, so it will be like 32x 31x 30, it will be go up to x comma 1. So this will be like how many times? 32 times. Here we can see that, clearly see that it will go, the control only calculate it inside 5 times, only 5 calculation it found the result. And here it had to calculate 32 time calculation to find out the optimum result. So this will reduce the time complexity. That's why we implemented these methods, and that's why we went through to understand this concept. So now we will see the practical implementation of our program, which will be like, so here this is our body of the function, and we are passing x and n, and this is our body, and here we call the function, and we store the value of this function inside a variable, and here we print a variable, right? So now we will see here what we write. We have to write the condition for n. If n equals to 0, then it will return what? It should return what? 1 only. Okay, then we have to calculate x to the power n by 2. Okay, for x to the power n by 2, firstly we have to like check whether n is even or odd. Okay, so if n equals to 0, then what should we write? We write log power of x comma n by 2 simply. Otherwise, if it is odd, not even, then we have to write log to the power of x comma n minus 1 by 2. We have to make it even, then we have to calculate the half. And now let x to the power n, what will be it? X to the power n by 2 into x to the power n by 2, right? But it is only for even. When we calculate for odd, then it will be if n modulus 2 equals to 1. If it is odd, then x to the power n will be x to the power n multiplied by x again. Okay, and now we will have to return what? X to the power n only. Okay, so this is our program. Now we will execute this. So it will be like, the result will be this one. If we calculate it properly, we have to reduce the value of n. Now this will be like 10,000, right? So let's check. This is 10,000. Okay, so now we have to check it for odd. Okay, this is 1 lakh, and if we went it for 3, then it will be like 1,000 only. This is 1,000. So our expected output is correct, and our program will be this one. I'll provide the link for this program. Over there you can go and download. I'll put the link inside the description. So we will meet in next video. Till then, take care and bye.